I've already gotten this problem started a little bit with the preliminary stuff. And what we're looking for here is fourth roots of a complex number. So here's your complex number z. To find the fourth roots, the first thing I need to do is use de Moivre's root theorem and set n equal to 4. Okay, so now it is the fourth root theorem, not just a generic root theorem. And then I'm going to need to know z in polar form. That's key. So I've done some of that right here. You can see this scribbly stuff goes over how to find the modulus, which is 4, if you pause the video and read through that. And then theta, which we get to this point where you have to decide, is theta pi over 3 or 4 pi over 3, right? Both of those angles would produce a square root of 3 in the argument. And we have to decide which one it is. If you look back at z in rectangular coordinates, this is saying left and down. To me, what that means is quadrant 3. So here's my angle, 4 pi over 3. It's not pi over 3. All right? So to write this in polar form, I would come through here and say, great, cosine of the angle is 4 pi over 3 plus I times sine of that angle, 4 pi over 3. There we go. That's my polar form of the complex number. And now, once you're getting good at de Moivre's theorem, this becomes the easy part. We have to find all 4 roots of z. The first step I like to do is deal with the modulus and get that out of the way, because once I have the modulus for one, I have it for all of them. It's going to be the same. What's the fourth root of 4? Well, that's like the square root of 4, right? Which is just the square root of 2. Great. So we can write it like this. We can say square root 2. And if you wanted, you could say the fourth root of 4, I guess. It wouldn't mark you wrong. So square root of 2 for all these things. And now we have to find the angles. Well, what de Moivre's theorem tells us is when you're looking for that first root, just divide the angle by 4. Okay, so let's go ahead and do that. What's 4 pi over 3 divided by 4? That is just pi over 3. Okay, pi over 3. That's our first root. And we could plot that on this little graph that we have here by saying, okay, radical 2 is about 1.5, 1.4. So I'm going to, I don't know, there. That looks about good. There we go. That is my first root, W0. And now for each of these next ones, look what happens. We are going to add 2 pi over 4 for each successive root. As k goes from 0 to 1 to 2 to 3, we're going to add 2 pi over 4 each time. So 2 pi over 4 is just pi over 2. That's 90 degrees. Now, pi over 3 plus pi over 2 is not the easiest thing to do in your head, right? There's going to be some common denominator stuff that needs to get worked out. But what you get is 5 pi over 6 for this one. Once you add, right, pi over 3 plus pi over 2, and that's going to be equal to 5 pi over 6 once you work through that. Okay, so let me clear that out of the way because I've got stuff to draw. And where is our next root going to go? Well, 5 pi over 6 is over here, and I know it's about 1.4, 1.5, something like that. So there's W1. And you see that's rotated exactly 90 degrees, which it has to be because it is a fourth root. And a fourth root is going to divide this coordinate plane of 360 degrees into 4 pieces. Okay, so visually, we can just project what's going to happen for all these other roots without actually going through the algebra. If you like, we can do it this way. I like graphically doing these things. So the next one is going to be 90 degrees further on. There it is. Whoop, right here. At that's going to be my W2. And then the next one, another 90 degrees. Just be careful you don't land on the wrong angle. I mean, the graph is kind of forgiving. I've programmed it to let you get away with quite a bit of error, but you have to give me a shape that looks a lot like this. So there's all our roots graphically. You can see what the angles are going to be, whether you like adding things, with algebra or with the picture. This is going to be 4 pi over 3. And the last one is going to be 11 pi over 6. Okay, so those are all the polar forms of the roots. And we have our picture. All that's left is to convert these into rectangular form, but we've done this a bajillion times, so you can probably work through that.